Good morning, everybody. Just to introduce myself, I'm Simon Barber. I'm the UK Managing Director of Assystem. And on behalf of the company, I'd like to extend a really warm welcome to everyone. Thank you for coming to today's event. The plan today is to focus on the current state of play of UK fusion. Personally, I'm really delighted. I think 18 months ago, we ran a similar event to coincide with the launch of the Fusion Report, a piece of work that Assystem commissioned at the Institution of Mechanical Engineers, whose illustrious building we're in today, drafted and published. And 18 months ago, I'd like to say it was great to see so many familiar faces in the room, but actually we were all virtual. So it was just a panel of us and the very excellent support from the media crew at the back. We were an empty room, so it's really great to actually see you in person. Coming back to the Fusion Report, the reasons why Assystem commissioned it is we saw a gap. And the report was therefore aimed at highlighting the enormous potential for the development of fusion energy in the UK, as well as the multiple challenges and barriers to actually realising commercial fusion. And those barriers are many. They cover engineering, financing, siting, safety, and security. The report itself actually received a really warm welcome from stakeholders. Those stakeholders were across governments, within the UK AEA, and indeed across industry. And it was there because it was at the right time to start to explore as a country the immense potential for fusion's future development in the UK. The report coincided as well with the UK government launching its first fusion strategy, and that set out what many of us feel balances an ambitious yet common sense approach to fusion. So today's event comes at a really great time for UK fusion because I think in the past 18 months we've seen so much happening in the sector, fusion becoming recognised more and more as both a realistic energy source, not just for beyond the 2050s, in the more near future, as well as the opportunity for UK to continue its leadership role in fusion. Of course, this has all happened against the backdrop of 3 different price levels and an increasingly complex global geopolitical situation where energy security is increasingly important. We've also seen the STEP project taking form, with the identification and announcement of the site in West Burton for the UK's first fusion reactor. And we've also seen an incredible amount of investment into private fusion. And that is helping to really stimulate an amazing commercial, operational and scientific community and key milestones amongst the various developers, many of whom already have plans to build demonstrator plants or test plants on the Culham site in Oxfordshire. We've also seen really strong growth in the UK fusion supply chain, and in many cases that's supported by and indeed guided by academia. So it's a real coming together of all parts of the sector. During today, we hope to bring together all of these elements. We will discuss them during the course of the morning. But now, it's my great pleasure to hand over to Andrew Bowie, the Minister for Nuclear and Networks at the Department of Energy Security and Net Zero. So Andrew has recorded the following video for us. I've seen it, it's great, so please sit back and enjoy. Thank you very much.
I am delighted to open Assystem's Developments in UK Fusion Energy, Skills, Industry and the State of Play event. I'm only sorry that I cannot be with you there today. As you all know, fusion has the potential to be the ultimate clean power solution, offering a low carbon, safe, continuous and sustainable source of energy. This is not science fiction, but science fact. Fusion promises a revolution in the way we think about energy, and Britain, as a science superpower, recognises the importance of unlocking the potential of transformative technology to drive forward the net zero revolution. The UK government is committed to advancing the growth of fusion. In line with our fusion strategy, launched in 2021, we're advancing over £700 million between 2021 and 2025 into the UK AEA's cutting-edge research programmes and facilities to grow the capability of UK industry and make the UK the global hub for fusion innovation. This innovation is already something that the UK is great at. I had the pleasure of visiting the Culham Fusion campus earlier this year and saw firsthand just how this facility has grown from a laboratory in 1965 to a vibrant and diverse science hub today, accommodating over 1,750 scientists, specialists and staff who are working hard to deliver fusion. Coupled with the promising scientific results achieved right here in the UK by JET and the exciting work of our international partners, fusion is closer than ever before. The next step for fusion is demonstrating commercial viability. We are leading this through the STEP programme, to which we have already committed £250 million to build the UK's first prototype fusion power plant at West Burton in Nottinghamshire. The site of a coal-fired power station will be transformed into a global hub for fusion technology. STEP won't just demonstrate the viability of fusion energy though, it will also advance a whole host of transformative technologies, driving innovation to develop the industries of the future. On top of this, the UK is leading the world in fusion regulation. The energy bill currently passing through Parliament puts into law our proportional pro-innovation approach. This work has taken us far. However, there is still a long way to go and we cannot do this alone. Working with the private sector is vital to take fusion from vision to reality, and private fusion is growing faster than ever before. The number of fusion companies worldwide doubled between 2016 and 2020, and private investment has reached $5 billion globally to date. The UK is already playing a pivotal role in the growth of private fusion. Just look at the success of firms fostered here in the UK. Kyoto Fusioneering have secured new investment base on their UK activity, and homegrown company Oxford Sigma, started by 2 engineers in 2019, have expanded their operations to markets such as the USA, Canada, Japan and across Europe. Major industry players are taking note of the UK's massive potential. First Light Fusion and Tokamak Energy have recently announced their intentions to develop new facilities here at Culham, further expanding the site's world-class capabilities. The unique technologies and amazing scientists and engineers at these firms and many other companies represented here today are bringing commercial fusion closer. The British government is committed and ready to work with the fusion industry and investors. We've invested £42 million into the Fusion Industry Programme, which aims to galvanise commercial fusion innovation through a challenge fund, and supported the Future Fusion Cluster, a community of public organisations and businesses collaborating at the Culham Fusion Campus. All of this affirms our belief that the UK is the best place in the world to do fusion, offering regulatory certainty, a growing and diverse supply chain, unique research facilities and access to globally unique expertise. Today's event is a great opportunity to hear about the future of our fusion from some fantastic panel members. You can look forward to fascinating insights on the future of fusion from Dr. Adam Baker from the Department of Energy Security and Net Zero, Tim Beswick from the UK AEA, James Partington from the Institute of Mechanical Engineers and Dr. Windridge on behalf of Fusion Energy Insights. You can also look forward to our second panel on some of the challenges facing fusion, featuring Bethany from Assystem, Dr. Khan from the University of Manchester, Dr. Morrison from Oxford Sigma and Andy Wilson from Kyoto Fusioneering. I do hope you enjoyed the exciting events today, and thank you very much for your time.
Good morning, everyone. I'm Dr. Michael Zdanowski, your chair and moderator for today's event, and I'm delighted to welcome you all to our event on fusion energy titled Developments in UK Fusion Energy, Skills, Industry and the State of Play, taking place in the historic manufacturing room at the Institution of Mechanical Engineers overlooking a verdant St James's Park. This event, as you've heard, is being brought to you by global energy transition engineering company Assystem, and it's also being streamed online around the world via a live webinar link. And a special welcome to those who are joining online. Like you, I'm really looking forward to a rich discussion and insights about the prospects for UK fusion following an incredible 18 months full of commercial, operational and scientific milestones, both in public and private UK fusion initiatives. In terms of today's run of show, I'll just run you through it quickly. We have 2 panel discussions, each will roughly last 1 hour. They will run consecutively. Our first panel, who you see here, will tackle the question, where next for UK fusion? What are the challenges and opportunities facing the UK fusion sector today? Our second panel will focus on the voice of academia and the supply chain. It will look at skills and innovation, the talent pipeline, investment and financing, R&D, international collaboration, security, and some of the other challenges facing the UK fusion sector. As mentioned, this event is being broadcast online, and we really want to bridge the digital divide. For those who are joining online, you can ask questions to the panelists in the two panels via the online chat function, so please feel free to do that. Finally, for those in the room, there are no planned fire drills, so if you do hear a fire alarm today, it is a real one. You will be marshalled out of the building by fire marshals in the room. So I feel as though the Minister has already stolen my thunder by introducing everyone, but I'm going to add a layer of extra detail and introduce our guest speakers today, who represent different parts of the UK fusion industry. I'll then hand over to them for a short introductory presentation for their thoughts on where we are in the UK. Turning to my left, Melanie really needs no introduction, but I'm going to introduce her anyway. Melanie is a physicist, speaker, writer, and science commentator on fusion. Many know her as the founder and CEO of Fusion Energy Insights, a platform which informs audiences on developments in global fusion. I've also got Adam Baker to my right. Adam works in the Department of Energy Security and Net Zero, where he leads the fusion team. Adam will give the government's perspective of fusion and will no doubt have perspectives on the importance of fusion to current government thinking. To my far left, we've got Tim Bestwick. Tim is UKAEA's Chief Technology Officer and Director of Strategy, Communications and Business Development. Tim has been integral to UKAEA's conceptualisation of the STEP project. We've also got James Partington on my far right, who was here actually 18 months ago with us when we launched the Fusion Report. James is Director of Engineering Policy and Impact at IMECI. James's previous role was at the Department for Business, Energy and Industrial Strategy, where he was Deputy Director in the International Science and Innovation Directorate. And to my immediate right is Simon Barber, who you've just heard from, UK Managing Director of Assystem. I'm going to hand over the floor to each of the speakers, starting with Melanie to my left. So Melanie, where are we with UK fusion?
Okay, so George,
Microphone, yeah.
who's this?
It's on.
Does it work? Oh, okay. Hello, everyone. Pleasure to be here today. So yeah, where next for UK Fusion? In my 3 or 4 minutes, I'm going to give you a quick rundown of some of the things we've achieved, because I think there's been really encouraging progress in recent years. We've heard a couple of the things already from the Minister, but things like the UK announced a fusion strategy in 2021, and then a regulatory framework in 2022. In the US, they announced their bold decadal vision in 2022, and just recently announced that they're going to be regulating fusion differently from fission as well. Just recently, we also heard from the Japanese. They announced their fusion strategy. So we've been seeing encouraging progress from governments around the world. There's also been private fusion company progress. So just in this country, First Light Fusion announced achieving fusion in their inertially confined fusion concept just last year. Tokamak Energy achieved 100 million degrees or fusion temperatures in their tokamak last year. And there's, of course, been public lab progress, which I'm sure we'll hear more about. The JET tokamak achieved 59 megajoules for 5 seconds, which they announced early last year. And then the NIF, National Ignition Facility in America, achieved ignition, which was big news at the end of last year. And we've also had private public lab progress announcements from the Chinese Tokamak East about long pulse duration. So there's been very encouraging progress in recent years. But where are we and what challenges do we have? Well, funding fusion is now a real challenge, because we're moving from the science phase, you could say, into the engineering phase. So how do we actually build fusion pilot plants and then fusion power plants? It's now a tougher market for funding than in the last couple of years. And some of the more mature companies are now looking to raise hundreds of millions of pounds or dollars to achieve their fusion ambitions. And so it's going to be difficult for some of these companies to raise the funding that they need. The next phase, we're going to be looking to demonstrate technology and building power plants, pilot plants, and that's going to take a huge investment of time and of money. So I think the big question now is, how do we cover that gap? How do we support fusion to get through this this difficult engineering phase to get to the first pilot plants and power plants. So how are we going to do that? We've heard from the Minister that public-private partnerships are going to be very important. We need to find ways for the private sector to work with the public sector. And we're already seeing encouraging steps in that regard. So in the UK, there's the Fusion Industry Programme. In the US, they've got public-private partnerships like Infuse, and they've just announced a milestone-based public-private partnership which is modelled on the NASA COTS program, which launched SpaceX. So that's very encouraging. But at the moment, there's not enough funding going into those public-private partnerships. The milestone-based program in America is currently for about $50 million. They're going to need more than that, maybe 10 times as much. So funding is going to be an issue. We also need to help investors to navigate this as well. Just last week, I ran an event in London called Fusion X Invest with some partners, and we had interesting discussions there. Some of the things that came out of that, we need to find new ways of funding fusion, maybe new models. Mark White, who's in this room, I believe, from the UK Innovation and Science Seed Fund, he said that in all the hundreds of companies that he's funded, most of them don't fail because of the technology. They fail for other reasons, like the team or the business models. So we need to find ways to support the private companies and new models for funding fusion. Investors also need a way to better judge progress in fusion, something like clinical trials in biotech that enables the investors to keep up to date with progress. So there are various things that people are that we're working on right now, but also various funding is going to be a really important thing. So it's great that we're seeing government commitments to fusion. It's great that we're seeing scientific progress, but there are huge challenges ahead, and we need to follow the aspirations with money if we're going to achieve the goals on a meaningful timescale.
Thank you, Melanie. I was now going to turn over to Adam, so for the government's perspective.
Of course. Morning, everybody. It's really difficult to follow my minister. He's so enthusiastic, and he talks to you all about what we're doing already. So I see government's job, I see my job as creating the environment for the sector to go away and deliver fusion. I don't think government's ever going to be in the business of building power stations commercially. So what we try and do is just put everything in place, put that bedrock in place to ensure that everybody else in this room can go ahead and deliver fusion energy. So in terms of what we've done already, the Minister mentioned regulation. I think that was really important because it gave the sector stability, it gave the sector certainty, and it showed that the government is actually behind fusion, that there is a future for this energy. And that's something we're really proud of. We can see that approach being adopted by the US, it's being discussed by other countries. Things like this are really important. It's a really strong signal to the market. And I dare say we'll talk more about regulation as that legislation passes Parliament, we get into implementation of that. The other thing we've done is sort out or give more certainty and structure to the R&D base that is next to all the commercial activities. So what we've done is funded a whole range of technologies at the UK AEA. We've developed the Culham campus, and we've invested in STEP. So STEP, the spherical tokamak for energy production, for those of you who don't remember that acronym, that's there to demonstrate that commercial scale fusion can be done, and done in a way with industry and others that is replicable. But it does more than that. It also stimulates the supply chain development. It creates a market in some more difficult times. So Melanie talked about the fact that it's more difficult to get investment for those really big construction projects at the moment. That's true. It's one of the things we need to deal with. But if you've got something stable like STEP, which provides that market for the supply chain, you maintain that capability in times that are a little bit rocky. You know, the market is cyclical, it always will be. So what UK AEA do is absolutely critical to maintain that stability over the next couple of decades when this technology will come to fruition. The next thing I want to talk about is skills. This is a really big challenge, I think, not just for the fusion sector, but the nuclear sector as a whole. And it's a global problem. It's not just a problem in the UK, it's a problem everywhere, and it's not something the government is going to solve on its own. So I think one of the things we really want to do is work with the sector to figure out how we ensure that pipeline of talent and pipeline of skill at all levels of the capabilities required for fusion. So we have the Oxford Advanced Skills apprenticeship programme. That's absolutely fantastic and capable of delivering really high quality apprentices in the hundreds. But that's not all we need. We need to partner with academia and the universities to make sure that there is that PhD level input. And we also need the sector to do its bit as well. It's not just going to be a government issue. So I'm really pleased to see the fusion cluster come together. I dare say Tim will talk a little bit more about that in a bit. And I know that the fusion cluster is talking about skills. So I think that's really important as well. But I think overall, if you're a nerd like me and you watch the Marvel films, I think what we've done is we're just approaching the first phase of fusion. We've got our main characters. We know what the world looks like. We know what the journey is going to be. It's now moving into the delivery of those things. And I think the government is certainly committed to supporting it. There are always issues with government in that we have politics to deal with. There are spending reviews that we need to go through. But the commitment is there politically at all levels. So this is a really good opportunity. And that political will, that regulatory stability, the bedrock of our R&D puts the UK in an absolutely fantastic position to lead this globally. And I think we're seeing that already.
Thanks, Adam. So some good perspectives and also some warm words from UKAA's parent department. I did wonder where you were going with the Marvel analogy there for a moment, Adam, but that was I understood it. Tim, turning to you, where are we with UK fusion and what's the perspective from UKAA?
Well, I was going to summarise the UKAA programme, but first of all, the Minister did it and then Adam did. Let me just say what an extraordinary asset it is to the fusion community to have somebody as passionate and committed as Adam leading our policy team, because it really does make a huge difference. And government commitment to fusion actually has been very impressive, I think, and Adam is in large part responsible for that, so thank you. I wanted to just sort of challenge a little bit of an assumption so far, and maybe this isn't in everybody's minds, but I think it is unhelpful to think of UK fusion and US fusion and private fusion and public fusion, because actually that's not really the reality of where we're at. Actually, fusion businesses are operating pretty globally. There are businesses in this room that are operating between the US and the UK sort of pretty seamlessly. And so geography is important to us, but actually we're in an industry that is global. It really is global. Different jurisdictions have embraced it with different amounts of passion. But you can confidently expect that fusion will be a global industry and it will be globally mobile. And so, you know, the order of the day is to do what we can to do our bit to make this work and obtain value from it. But it's not a parochial industry. And the second point I wanted to say, if I can not go too far off my brief, is that actually it is tempting sometimes to talk about public fusion, the big international projects such as JET and ITER and NIF, or private fusion, the agile companies. But I think the reality is that delivering this incredibly complex, difficult technology to market that will have such transformational benefits is something that inevitably requires the public sector and the private sector working together in harmony. So that just leaves us with the task of figuring out how to do that most productively. So UKAEA has sort of reinvented itself in recent years. For a long time, we were the hosts of the European JET machine, the deuterium tritium tokamak, that's been operating for 40 years. Actually, its 40th birthday is in July. Way beyond any time that anybody would have thought it was doing fusion research. But that's now coming to an end. We're going to turn it off at the end of this year and move on. And UKAEA has changed from being focused around one big machine to disassembling the field of fusion into component parts and developing centres of excellence in each of those. So, for example, we have a tritium handling facility. I think probably the largest civilian tritium R&D facility in the world, where we're looking at the business of managing tritium, which is likely to be a key fuel in almost all versions of fusion. And other aspects of fusion technology too, be it robotics or plasma confinement or the other aspects. So we've set up centres of expertise in those, and we are looking to and are collaborating with both businesses, fusion companies, and the great private public experiments on fusion. So those centres of expertise are important to us. In there also, we have also started the STEP programme. It's been mentioned before. This is a pretty substantial and audacious move backed by the government to build a prototype fusion machine. And we've chosen one particular approach, and we're going to deliver it through a set of private sector partners. So the intent is not that this is a public sector activity delivered by the government. It will be delivered by industrial partners. It will, as Adam said, stimulate the base, the supply base, and act as a driving function. It's audacious because it's looking to deliver a power plant using technology that, as we all know, is unproven. It's still in the lab. But we think a very focused, bold program like that is an important way to make progress. There's a but. Alongside those focused, bold programs to deliver a thing, in the STEP's case, a prototype fusion power plant based at West Burton by 2040, you also need the breadth of capability and R&D strength to back it up in all the fields that will need to deliver. And that breadth actually backs up not just the STEP programme, but all the other private sector initiatives that are going on. So to make progress in this field, we need a whole bunch of focused, targeted, bold, ambitious programs. We need an underpinning R&D activity, and there are a whole bunch of underpinning activities that in fusion we need to put more oomph into to make progress. One of the obvious candidates at the moment that we need to make more progress in is around the application of advanced computing to fusion. That's an active topic. So it's an exciting time. It's an exciting time where we've, I think, all collectively realised that public-private partnerships are the order of the day, and making those work most effectively is important. And there are still some actually key aspects of fusion that we have to collectively grapple with and make more rapid progress.
Brilliant. Thank you, Tim. I'm going to move to James now. So thoughts from Tim there about the sort of geography is important, but there's a global industry in public and private. And I know you've spent time in government and outside of government now, being at IMECI for, 6 months now. So, James, what are your perspectives?
Yeah, thank you. Thank you very much. It's not often I get to sit with Adam on a panel because we used to kind of divide and conquer, but it's great to be here and it's great to be back and talking about fusion. And I wasn't actually going to focus on that angle, and I was actually thinking about what I was going to talk about, and the problem going forth on a panel is often many people say the things you're interested in saying anyway, but I still think there's one thing that we can unpack, and Adam touched on it, and it's about the skills, and this is a global problem. And we've talked quite a bit about the fusion strategy that was published in 2021. That set out two main things: demonstrating the commercial viability of fusion and building a world-leading fusion industry. The Minister has set out his commitment to continue to grow the UK fusion community, but you won't build a world-leading fusion industry without a world-leading fusion workforce. I wanted to talk a little bit about the people. And that strategy talks about attracting and growing and retaining our fusion talent. But I think maybe it's a good time to start thinking about how we do that. Because Melanie, you talked about turning science to engineering. We're an engineering institution. This is about how we build these things. And this is starting to think about how we turn this from a science problem into an engineering problem. Ian Chapman has talked about, I think, beginning to map the future skills workforce and the STEP Skills Centre at West Burton. We talked about this being a global problem. I think, like from some of my panel speakers here, we know that this isn't something about, is this government and STEP or is this the private sector? not only is there going to be competition, and if we're not careful, you're going to see, I guess, companies trying to pinch top talent from one another, maybe other countries trying to pinch top talent from the UK. Great British Nuclear's looking to launch and announce there's plans for SMRs later this year. There's gigawatt scale programs. There's other mega projects. There's going to be a lot of competition for the same people and the same skills. And I think what we really need to start seeing is the sector-wide fusion skills strategy. And Adam mentioned, we're not starting at this cold. The Oxford Advanced Skills Academy is fantastic, does great things. It trains, I think you said, hundreds a year. I think we get about 50 PhD students a year at the moment. But I think that's going to fall quite a long way short of our skills demand in the workforce. It could be as many as 2,000 people. I think it's quite clear that demand is going to outstrip supply. So I think a sector-wide fusion skills strategy will help mitigate some of those risks that companies might start pinching talent. And I thought it's easy to call out the problems, so maybe I quite liked doing the policy work in my previous career, so I thought I'd set out some thoughts on that as well. Profile. Here at the Institution of Mechanical Engineers, we do a lot on outreach. We go into schools, we get people interested in science, technology, engineering and maths. We get people interested in engineering. What we actually see is a shift in what people really care about when they think about their career. And younger generation now think about their values and what is it that they want to do in their career. And they want to be involved in things that address sustainability, address climate change. And I think what better than fusion to turn people's heads and to attract them into a career in engineering? They might not end up in fusion, but I think the opportunity of fusion is fantastic for profile for engineers and future engineers. Second is destination. We've talked a lot about the UK here being a world leader. I think there's like a pretty good test that you're not really a true leader in a technology, global leader, without a global workforce. I think we see that in the UK. The Minister talked about the private sector investment that we've seen in the UK. There's reasons why people are investing in the UK. But that is certainly, I think, something that's a foundation and a real strength that we shouldn't lose in the UK. And thirdly, clustering. We mentioned the fusion cluster, but I think it's easy to forget that fusion clusters, well, clusters in general, are like they're hard-won things for technology, but they're easily lost. And we shouldn't underestimate the value of, like, those conversations that you have. You can go and talk to other engineers facing similar but different problems. You can talk about the challenges, you can talk about the opportunities, the ways of doing things. That's a fantastic way to continue to upskill people on like a day-to-day basis. And I think thinking about that clustering value for the UK skills strategy is hugely important. And you bring that together and you start to get an authoritative voice about what we need in the UK for fusion. I think that can promote the opportunities, dispel myths, allay concerns that the public may have about fusion. Not everyone's a fusion evangelist like us here. So I think it's a real challenge to coordinate the fusion workforce. But that must be seen as an opportunity as well to do just that, to coordinate the skills of the fusion sector. I think a sector-wide fusion skills strategy would benefit both companies, but also the science and engineering professions alike. Thank you.
Thank you, James. So we've got a bold call out for and call to action for a fusion skills strategy from James. So hold that thought. And do remember, if you are joining online, please put your questions into the online chat. We will share those questions with the panel. Turning to my right now, Simon, MD, UK for Assystem. What are your thoughts?
I think firstly, it can be quite a tough ask to welcome everyone to an event and give some early perspectives and then to be part of a panel. But I think in fusion, there is so much happening that actually there's an opportunity to, I think, deep dive into a couple of areas and give some of my perspectives as the UK MD of Assystem. So firstly, I wanted to talk a little bit more about STEP. STEP for me is an incredible leadership opportunity in fusion for the UK. Scale and ambition should really be commended. For me, it's an opportunity to really establish a platform for public and private collaboration in fusion. And I think that's really crucial because the scale of the challenges that we face in commercialising fusion really dictates the need for new engagement models, not just for companies that are already mature and operate in the energy sector in all its forms. But companies from outside the sector who are perhaps looking at fusion for the first time and want to transition into energy. And indeed, on the timescales that we're talking about, companies that today have not even been created yet, but will play a role in fusion in the future. I think, picking up on Tim's points around global mobility, I think the fusion sector should be applauded for its ability to mobilize people from that global community into centres of excellence of fusion around the world. And I think whilst there is a risk to the UK that with the ITER projects, which I'll come back to in a little while, the ITER project in the south of France, very quickly it's come out of the ground, key parts of the equipment and components are now being installed. It's the bright, shiny new centre of excellence for fusion. And I think what UK AEA has done incredibly well is firstly by launching STEP and also by attracting private fusion companies into Culham, is actually maintaining that position that the UK has as the global centre of excellence for fusion. And I think that's really important that we use that to stimulate a new industry sector, to stimulate academia, to capture the hearts and minds in schools and the skills agenda, because we're here now to create that decadal-long systematic platform for industry and academia to really get behind STEP and to deliver it. And I think within that, it will be really interesting for me to see the interplay between private and commercial fusion, public and private fusion. So how the commercial developers move forwards, how knowledge is shared, and how that evolves to deliver successful outcomes for the sector, not just for individual companies. I mentioned ITER briefly, and we haven't talked about ITER too much today. So I just wanted to add some perspectives from Assystem. ITER for us has been a 15-year journey. So we are part of the Engage Architect Engineering Consortium that started work on ITER in 2009, has delivered the design for the power plants, and is today providing that construction integration role on what is clearly an incredibly complex, first of a kind global endeavour. We're also part of the Momentum Consortium with Jacobs and KHNP, which is providing the construction management and the design integrator services that are bringing that plant together on the site. And through that, we bring an incredible amount of perspective on how to take a complex fusion plant off of paper and into reality, and integrating components that have been delivered from around the world, in many cases stretching the art of what's possible from an engineering and a technology perspective, and bringing those together in Cadarache into a working fusion plant. And I think this is all an instructive example of how collaboration, in this case intergovernmental, and coming back to my earlier point about some pretty tough geopolitics at the moment, and how that can lead to big and positive results. And I'm hopeful that in the UK we can draw on those perspectives and take on board the learnings from ITER, both good and bad, for the benefit of the STEP programme. After all, we are a global sector, we are a global industry, and we're all working towards the common goal of seeing commercial fusion energy within our lifetimes. Both Adam and James touched on skills. And actually, we can't look at fusion in isolation when it comes to skills. The challenges that the energy security strategy in the UK, and indeed the energy transition globally, is bringing is absolutely huge. And in the UK, we couple it with real growth, significant growth in the defence sector. So the types of engineering and technical graduates that we need to come out of our universities are in really short supply. I'll give you an example from France. So France is embarking on a new EPR2 programme. That programme will be 6 + 8 reactors. The current estimate is that France, who has an incredibly mature nuclear fission sector, needs an extra 100,000 people to come into the sector in the next 10 years. So the scales of the challenges we're talking about to deliver the energy transition globally is absolutely huge. So for the UK nuclear programme to be successful, we absolutely have to maintain that global mobility of skills. And we have to compete on a level playing field with other areas of the sector, whether it's hydrogen or nuclear fission, renewables, to attract people into a nascent and incredibly exciting sector. Everyone in this room with an interest in developing fusion energy will have to come up with a compelling proposition for why people should come into the sector to enable it to grow. And we can't just rest on our laurels and expect others to come into the industry. So James's point about what the Institution of Mechanical Engineers is doing around that early skills engagement is really important. For me, 10 years ago, I think the offshore wind, the renewable sector, did this incredibly well. And we saw a whole cohort of engineers going into universities, into degrees in environmental energy or energy engineering, and all coming out wanting to build wind farms. We have got to make that similar call to arms and capture those hearts and minds if we are to be successful. We can't be exclusive in the UK, so we do need to look at that global sector. We do need to encourage companies and people into the UK to help to deliver fusion within the UK. And if we do this, the UK can and will remain one of the best, if not the best locations to develop fusion energy in the world. Thank you.
Thanks, Simon. So some really interesting and different perspectives from our panelists here. I'm just going to do a quick recap. So Melanie talked about how do we cover the gap between financing and engineering, and looked a little bit about the public-private partnerships. Adam talked about government putting the bedrock in place for fusion to be successful in the UK. Tim talked about the fact that geography is important. There is a UK industry, but actually we're part of a connected global industry, and that the public and private sectors must act in harmony. James gave a great call to action in terms of a fusion skills strategy and the need for that, and also the importance of clustering and how that has a multiplier effect. And then Simon gave the perspective as MD of a UK engineering company, and focused in particular on skills, but also with some learnings from ITER. So we've got loads of topics to explore. Before we turn to questions from the floor and online chat, I'm going to ask a couple of questions to the panel to get the ball rolling. So turning to Melanie first, and feel free others to sort of join in. It's 18 months since we last sat here. How excited should we be by global developments in fusion and particularly commercial financing? And how can the UK specifically capitalise on these developments?
I think that we should be very excited about the progress that's occurred since we were last sat here, and the global developments. I think it's really encouraging to see governments like the UK, the US, Japan as well. So not just one government, but multiple governments saying we think fusion is serious. We think fusion is important, and we want to be part of developing it. And we also want to get some of those economic benefits from developing it as well. So I think that that's really encouraging. But yes, we do have to work hard on actually making it a reality. And we've heard today that the public-private partnerships are going to be like really pivotal. It's not us and them with public and private. So it really is just about coming together and figuring out how we make that work to achieve the pilot plants that we need.
Okay, anyone else would like to take that on? How can the UK capitalise on recent developments?
Well, I'm just going to, is that working? Yeah, I think so. I was just going to point out that, it's incredibly exciting. What exciting technology, what exciting sector. But it's not without risks. It's an incredibly high-risk game. And I think we just need to be mindful, because it's very easy to get caught up in that hype that this is going to save the world. But there's some huge engineering challenges. You talked about ITER. I think it's the biggest engineering program in the world and a project in the world. And it's just something that just to temper that enthusiasm, because it's very easy to get caught up in that hype of fusion's here, it's going to fix everything, and isn't that fantastic? I mean, it is fantastic, and I believe that we will fix it. But there's some big challenges to be overcome on the way. And it's great to see the money pouring in, because I think that means there's a lot of people who've done a lot of due diligence, who have thought a lot about the technology and the potential and the opportunity. And I mean, to me, that's hugely exciting when I start to see that money flow and the private sector investment come in.
I suppose, can I add that another thing to remember when like James is quite right, that when we're thinking about the risks of fusion and the fact that there's still a lot of challenges, a lot to do before we get there, is to also think of the, let's say, intermediate opportunities along the way. And by that, I mean things like the enabling technologies that are being developed. And there are two sides to it, because there are enabling technologies that are needed to get fusion to the finish line, if you like. But there are companies like Kyoto Fusioneering and others that are coming up to to develop the technologies that we need. And so there will be opportunities there. But also there are private companies and also the UK AEA spins out technologies that are developed within fusion that can then have other applications. And so I think that it's important to remember that while fusion is the big goal that everybody's working towards, there are other opportunities, like investment opportunities or economic opportunities that can come from technologies that are being developed for fusion and within fusion.
I guess, Tim, coming to you, Melanie mentioned a number of those sort of enabling technologies, and that will be absolutely crucial for STEP. You talked about public and private. We've got a kind of ecosystem growing of companies here in the UK, many of which are represented in the fusion cluster. So how do we capitalise on that? Where do you see the next sort of 10 years going if fusion, commercial fusion itself is, still some way off?
Yes, absolutely. Fusion doesn't really spend much in the supply chain at the moment. I mean, it's. I think I've before pointed out that the latest survey, which showed $500 million being deployed in the supply chain, is about 10% of the global market for mascara. So, we're not yet hit the big time. So one of the key challenges is just to stimulate the supply chain with. Actually, in the case of what is happening, certainly in this country, with public investment. I think Melanie touched on something that's really important to our sector and we haven't done enough of, and that's spillover technologies. But broadly speaking, you can't have people working so hard on fusion, which is so difficult, without inventing a whole bunch of stuff that's useful someplace else. I mean, I'm trivializing slightly. But those spillovers will be really important to us for at least two reasons. One is that actually the technologies that we need to build fusion plants need to be matured. And actually, one of the best ways to mature a technology is to find a whole bunch of applications for it, use those to mature it, and then make use of the technology. Because we don't want to be the single customer for a lot of what we do. So part of it is just actually maturing the technology for our future use. But another key reason why we as a sector should put more emphasis on spillovers is because, and Melanie touched on this, is because actually the investment case for fusion is still quite tough. Fusion, the commercial outcomes for fusion are generally beyond the horizon of most investors. Not all, obviously, because the sector's raising investment, but beyond the horizon of a lot of investors. The more we can show short-term benefit from what we're doing, the easier it is, frankly, to raise money and put money in the sector. So I think what underlies that question is really important. We need to keep our eye fixed on the long-term goal of delivering fusion energy, which could really be transformative, but actually have a good deal of emphasis on identifying technologies on the way to doing that we can use elsewhere, generate economic value from, and mature for our sector.
Would anyone else like to come in? Adam?
Yeah, sure. I mean, I agree with that wholeheartedly, as you'd expect. And I think, in the past, fusion has or may have had a bit of a sort of a credibility problem, both in terms of investors, but also in terms of public perception. And I think whilst this remains a public-private partnership, government is going to need to invest, and that means that there needs to be public support for fusion. And I'm not sure that we've really got our act into gear when it comes to public perception of fusion, public perception of risk, and what we need to do to raise the profile of what could be this transformative technology. So in bringing forward these intermediate gains, these spin-out technologies, the things along the way, that really helps to build that credibility for investors. It also really helps to build that credibility both for governments and for the public as well. I think it's absolutely essential, and I agree with Tim wholeheartedly that it's something we need to do more of as a sector.
Yeah, I just wanted to stay with you, Adam, because I had a kind of follow-up question. So we've got, let's say, potentially intermediate technologies coming online here in the UK, developed by UK companies or international companies operating in the UK. So is the UK's investment in fusion something good for the UK, for kind of the future energy system, energy security, or is it a potential global export opportunity? What are the government's thoughts on that?
It's both. It's not one simple thing. I think the case for investment in fusion, you think about the economic advantages of leading that global market in fusion. I mean, those, I'm not sure it's calculable, what those potential economic gains of the UK could be. So, who knows, but it's worth trying. It's always worth investing in that. But fusion is a global need, and climate change is not a UK problem, it's a global problem. So these are things that are needed globally. If we can help the UK economy along the way, then that's absolutely fantastic. But this is a climate change technology, I think.
Okay, and in terms of the UK potentially having a kind of global export potential, how do we retain the IP and skills in the UK? And sort of want to widen the question out to all of you here. How do we retain the IP and skills and looking at the next sort of 20, 25 years?
Yeah, and I think for government at least, it's creating the environment that makes the UK the best place to come and innovate in fusion. So if the work is done here, if the skills are here, if the investment is here, then the value to the UK economy will be here. And I think that's, if I think about my work, not just now, but in the future, it's absolutely critical that we don't sit on our laurels with this one. I mentioned before, we've put the bedrock in place. We've got really good R&D. We've got the basics there. The question for me and for the rest of the panel actually is not just, is that the right thing, but what's next? How do we expand that support to genuinely make this the place where it's absolutely blinding obvious to anyone who wants to do fusion that you come to the UK to do it.
Okay. Any thoughts, Simon, on that UK skills piece in terms of retaining UK skills and IP?
Sorry.
You've got mine.
I think I was just thinking about fusion then as a global sector and thinking about materials and material supply, and fusion uses some pretty exotic materials, and there's a continuous R&D programs within those. I think for me part of the solution is where you have components that are unique to fusion, then creating centres of excellence for the design and manufacture of those within the UK where we can. I think is a key part to doing that, because the scale of some of the components means that it's not a simple matter even to build a factory. So I think that first mover advantage in some of those areas to support a homegrown commercial fusion program can then be used as a very substantive base for exporting technologies as well. So I think that's a key part of it for me.
Okay. Just one question from my side before we go into questions from the floor and also the online forum. We've seen US developers attract a lot of investment recently. clearly with that go big salaries. How do we sort of maintain that UK leadership position when, you know, there's a potential for some of our best talent to move to the US where, let's face it, wage structures are different and often higher. So I don't know if anyone would like to take on that rather challenging question.
Not really a fusion-specific question, is it? I mean, are you suggesting that it should just be a sort of quadruple of all our salaries? It's an interesting idea. Maybe, what do you think? Good idea? There's a ripple of support for that, I think. I think that's a structural issue that's a bit beyond our sector. So plenty of people do move. I mean, I just make the general observation that skills and talent are always the scarcest commodity in a new high-tech sector. Other things like the supply of capital or equipment can come and go, but you know, skills are the key bit. And people are. You're alluding to something that's really important. People are globally mobile, so people do move. We've had plenty of people move from UK AEA, and I expect that will continue. There's not a great deal we can do about it, though.
I'm going to try and tie those two questions together a little bit, because I think facilities are sticky and people less so, and much harder to move ITER to the UK as much as we might want to do that. But these things are engineering challenges, and people are motivated. I talked at the start about changing the world and doing things to make a difference and to address the world's biggest issues. And some of this now verges into geopolitical realm. And I think you'll see engineers who are there who want to make a difference and work on the biggest projects and go to where the science is cutting edge. And so they might pay more, but if we continue to invest in our facilities and we have the industry and the cluster and the momentum and eyes in the front of the head and keep working on R&D and working forward, people will come and work here. And I think that might be one of the factors into that problem that you just posed.
I agree. I think there's only a certain finite amount of time where projects are paper or data projects. And we set up globally now to be able to deliver the design of facilities anywhere around the world. That's part of the attraction, but as soon as you move into tangible facilities being built and facilities being operated, that's what really attracts big parts of the supply chain. And then you have got those anchor through real physical infrastructure that people want to come and work on, that really creates that coalition. So we need that build certainty. We need to have at the appropriate time a clear policy and a programme for delivering fusion, and that's what will attract people and keep them in the UK.
Question for Adam. We've had a really sort of positive vision painted of UK fusion. Where are the gaps in terms of UK government policy from your perspective?
I think there are still things we have yet to do. So I think we've been working on this for a little while now. But as I just alluded to, there are next steps. So I think thinking about an investment strategy, thinking about an industrial strategy for fusion, and thinking about a skills strategy for fusion. These are all things yet to be done. And having got the basics in place, there are things that we can do kind of going forward. So I'm lucky that my team is growing. We intend to do some of these things going forward. We need to agree all of it with our ministers, of course. But I think everything that we've been talking about is absolutely in our heads as we kind of move forward.
Okay, thank you very much. I'm now going to open up to questions from the floor. So if you've got any questions, please put your hand up, identify yourself and your organisation, and then we'll come to the online questions.
Hi, Esme Sallard from BBC. Thank you for the panel. That was really, really interesting to get an oversight of where we're up to. It's obviously clear there's a lot of passion, interest in this sector. I think something that strikes me, obviously, and you keep mentioning, is the lack of finance, and particularly for industries that are kind of, I guess, not yet at the commercial stage. Obviously, the government plays a key role in kind of stimulating that investment. I guess comparing maybe to investment in space, it's similar in terms of the scale of the challenge. I mean, the minister mentioned 74 million investment. I mean, the government's recent investment in space was closer to 2 billion. It's very, very different. So I'm just wondering if there are moves to invest more and how we can stimulate that investment. And I guess linking that to skills, what can the industry do to kind of increase the awareness of fusion as an industry? I mean, that's something that we're obviously, we're interacting with the public all the time about that. So kind of a twofold question there.
Okay, who would like to take that? So a question about the structure of future investment and also skills. I'm looking at Adam.
Yeah, I can start this one off. So you're absolutely right. Different sectors have different investment from government, and a lot of that is to do with the stage that the technologies are, how far it is towards commercialisation, and what investment needs to be at any particular given time. So we in the Fusion team will always look at what's needed when it's needed. We'll talk to the UK Atomic Energy Authority. We'll talk to the sector. We'll talk to the academics. But it's for us, it's always what's needed where, and we'll continue to do that in sort of future years. But at the moment, the figure we've invested so far up until 2025 is 700 million just in this spending review period. That's quite a chunk of money for a new technology. So I think the government's actually doing pretty well in terms of investment. But you're right, and we'll need to look at that again as we start to further the work with STEP. As we start to bring fusion towards commercialisation. And we'll also need to look to the private sector and to commercial entities to see what part they want to play in investing in things like STEP and commercial fusion development.
Any further thoughts from the panel?
Can I make, sorry, can I make a quick, add a quick thought on skills? I think as well that it needs to start really early, like talking about skills. When we're talking about people having an interest in STEM or science, technology, engineering and maths, it starts really young. And so we probably also need to be talking to the Department of Education or, getting into the curriculum bits about fusion. And because there's always pushes to get more people into STEM. I've been involved with them in the past, but we probably do need to talk a little bit more about fusion, because we've seen in recent years that students come up knowing all about renewables and wind and solar and really keen on sustainability kind of careers, but fusion isn't part of that because I suppose it's always been seen as too far away. So I think we need to be having conversations with education at the really early stages and getting it into people's minds, like in the formative years, and then following that through. So it's a long process, but I do think we need to be like going quite a way back as well.
I think that the next, yes, Tim.
Yeah, I was going to agree absolutely with Melanie. I think, as far as I know, the evidence suggests that people make decisions about where they're going to head for their career at a very early age. And I think that there's a real place and appetite for using engaging, exciting science, be it space or fusion or something else, to really open children's eyes to the opportunities of careers of working in that field. And actually, I think more and more, you're from the BBC, so you know more about this than I do, but I think more and more of that has been done recently, and it's great. But there's still a real challenge. I mean, there's still media perceptions of science and technology, and I think in particular maths. I think real social attitudes really hamper people entering the field, and I think we really should do what we can to show that there's really exciting opportunity in science and technology at an early age.
Yeah.
Capture people's imaginations. If fusion can play a part in that, that's great, but it's a much bigger piece than just our sector.
Yeah, I was just going to ask a rather obvious follow-up question from Melanie's insights there around STEP. How do we get people in the UK interested in STEP? There is a public perception piece, and I know we've got representatives in the room from Nottinghamshire. So how do we get people interested in STEP in terms of that general public perception piece?
In that particular project, or in fusion in general,
in
or
STEP,
both?
I think.
Gosh, that's a big question. I mean, first of all, there's something about fusion that's an adventure that I think makes it appealing and exciting and engaging. We're trying to harness the power of the sun, bring it to Earth as a practical power source that's going to power our futures without generating carbon. I mean, this is all, this is the elements of a great quest. And so there's the beginnings of a narrative that I think, is exciting. The starting point is exciting. I guess we just have to tell that story in lots of different ways to lots of different audiences. And there will be people who are excited because of the climate implications. There are people who are excited just because of the science involved, and there are people who will be excited because of the scale of the technology. They're all exciting aspects to it. So I think there's a story there that's great. I think telling the narrative I would leave to the storytellers, but it's an important thing to do.
Okay, while I've got you, there was I'll come to you in a moment, James, but there was a question from the online webinar audience. How many jobs could fusion create in the UK from STEP alone?
Lots. Do you want to be more?
Good answer.
Do you want to be more quantified? I don't have a number, but I would just point out that bringing a new energy technology to market is a huge scale program. I think if we talked a little bit about ITER and the number of people. I think doesn't Assystem alone just have 500 people on site? I heard. And that's just a part of a big project. The scale of big energy infrastructure is enormous. It does need huge numbers of people and highly skilled people, and the employment implications of bringing this technology to wide-scale application will be enormous.
Okay, I was reminded last week of the factoid, and I'm sure someone will correct me, that the Apollo space program in the US in the late 60s employed around 400,000 people. So, the big challenges require big workforces. James, I could see you wanted to come in.
Yeah, I was just going to, I don't want to open a whole conversation on what drives people's choices in careers. Parents are a big factor, but understanding and awareness is key. Adam talked about Marvel. You could write it into a plot line. I joke, but I don't joke. If Doctor Who's TARDIS was powered by fusion, wouldn't that be great? Kids watch this stuff. They understand it. You get it out there. There's different ways you can do this. And I think you can be quite creative as to how we go about doing that. That'd be fantastic. Went to fusion-powered TARDIS.
Okay, any more questions from the floor? This gentleman, Jack.
Thank you very much. So my name's Craig Taylor from Bassett Law District Council. And we'll be host at West Burton to the STEP site. And we, as a council, are hugely excited by that opportunity and really supportive of making it a success. Just picking up on the last point, we have been working very closely with Tim's colleagues from UK AEA in terms of trying to engage young people. So we've got a What Next Careers event, which attracts about 1,500 young people. And UK AEA will be attending the next one of those that we hold. We've also been having a festival of curiosity, which has been held during school holidays and fun-based activities. Again, UK AEA very strongly on that. So we're working a lot to try and engage the local young people. The question really, and the point I want to make is for Adam around, you talked about the public perception and the need to create the environment that STEP and fusion can flourish in. And from a local perspective, people are supportive of STEP. They don't have the concern regarding the nuclear connotations. It's more some of the practicalities of the infrastructure, because West Burton, it's in a rural location. So really it's around making sure the policy side of things considers through Department of Transport or whoever future investment at the very early stage, because there will need to be new road infrastructure, a new bridge potentially into the nearest largest settlement in Gainsborough. So it's really a plea and just pointing out the fact the infrastructure and practical needs of getting multiple thousand people to a site is going to be really key in local people's minds. Thank you.
Okay. Do you want to answer that?
Yes, please.
Yeah. It's something we're really cognizant of. There's a lot to building a power station. There's the planning. There's working really closely with the councils, with Department of Transport. Part of my team's job is to make those links across government. The fusion strategy is a government strategy. It's not just my strategy. That's what we'll do. We'll join up together, and this is something which has got support from the highest level of government. It's not just me and my team beavering away in a corner.
I think in terms of that, just the concept of delivering big infrastructure in rural areas, I think there's clearly a huge amount of learning from Hinkley Point C, and then indeed for Sizewell C. Hinkley Point C, and it picks up on the supply chain question, employs over 20,000 people in the supply chain in the UK alone. But a lot of the equipment for Hinkley is coming from the continent. But there's up to 10,000 people working on that site, and it's pretty hard to get to. And Sizewell's worse. So I think in terms of that logistics about how you deliver mega projects in rural locations, and in particular think about the local social values and the community benefits. We've got that as part of the DCO process for that major infrastructure, but it's a really important part because you're coming into an area, the move of West Burton from fossil to fusion is a really great narrative. But absolutely, as part of delivering it, there has to be that long-term legacy and benefits into your community in Bassett Law and indeed the surrounding communities. So I think focusing on what the project can deliver in the area as well, I think is part of it, and actually that is then part of the whole hearts and minds piece, whether it's attracting STEM or whether it's attracting let's call it the non-STEM. Sorry, that's probably a better term for it. But the people who will provide the HR and the financing and the catering and the security and all the other industries and skills that go into building and operating a major piece of infrastructure.
I mean, just to add a level of reassurance as well. West Burton A was picked for a reason, and part of that was the links. There's a railway line there, having the river nearby. So this was all considered really well and really thoroughly by the UK Atomic Energy Authority. They did a really good job. So I think you should take that as reassurance.
Great. There's a question from the online chat actually that's I think we just touched upon there, but it's relevant for STEP and North Nottinghamshire. How do we attract people from other parts of the global energy sector into fusion? What's the kind of pitch? I know North Nottinghamshire and that area, South Yorkshire, etc., former coalfields, it's been known as a centre for energy production in the UK for many years. So that's another kind of part of the jigsaw puzzle. But how do we get people with different skills into fusion with a view to STEP in the wider fusion industry in the UK?
I suppose it's about communicating the vision that we have for the future, or for the future of energy. Fusion will be clean, no greenhouse gases, no longer radioactive waste. And if you want to have a long-term sustainable energy solution, then fusion needs to be part of the mix. And so I think that communicating that vision effectively and bringing people along with that is then going to attract people who have a similar vision and who want to be part of the energy transition or part of the energy solution. And if we were mentioning before, that cutting edge science and research and development, that attracts people who want to be working on exciting projects. And so I think it's about communicating the vision and the excitement of fusion and what it is that we're trying to do, and that should attract people to take part.
If I could just add to that, I think for me it starts with policy, and then it starts with having a funded plan, and then seeing tangible delivery of milestones on time. I think one of the lessons that we perhaps learned from Hinkley Point C is that there was that huge call to arms around 2009 to the supply chain to come and invest now in the skills that HPC will need. In reality, that call to arms was probably about 6 or 7 years too early. So we have to get the signals out into the market, out at the right time, and then we have to demonstrate and provide confidence to that market that we're delivering on time.
You're right, so it's all joined up. So the vision is connected to the actual plans and the strategy.
Exactly.
Indeed.
I was going to give a reflection of moving from working in government to coming to a membership organisation like the institution, Mechanical Engineers. And if there's one thing engineers have is a deep interest in technical and science-related issues like fusion. We've got 115,000 members around the world. They're not all going to go and fix the problems in France, as you listed, but they are interested, and we can put out information to our members, and we do, and we talk to them about things like this. We run L&D events, we run seminars, we run programs, and there's a huge amount of the workforce that will be required already in work at the moment. We provide continued professional development and training, and people will be interested. And through organisations like ours, I think you can get out, and we've got the civil engineers next door. We work through organisations like ours to get out messages to people, to have that conversation, to understand the opportunity, and then people will want to get involved in fusion. I mean, as I say, it's an inspiring technology, it's an engineering challenge, and you open up that conversation with membership organisations like ours. I think that probably a pretty good first step to moving that to answer that question.
Thank you. Any further questions from the floor? Gentleman at the back.
Hi, thanks. Fred Chung from Sizewell C Project. Thanks very much for the interesting discussion. The panel spoke about financial challenges of fusion development going beyond the typical investment case horizon, and perhaps creating intermediate spin-offs and as well as public investment as solutions. Just wondering whether the panel had any thoughts about the sources of private capital that's needed to develop fusion beyond these intermediate technologies. Thanks.
So, private investment in fusion. Melanie, is that one you can take on, given your global links?
It's a difficult question. There are private investors in fusion, but they tend to have longer time horizons than the classic VCs. There are, as we said, some spin-off technologies, so hopefully that could attract some others, just to show that there might be income or revenue coming sooner, so it might fit into smaller time horizons. But it's actually a big challenge, and it is something that needs to be resolved. Or I don't know the answer really, like how you close that gap. But it is something that I think people are becoming increasingly aware of, and hopefully the public-private partnerships will help to give investors certainty. Do you want to comment, Tim?
I agree. It's difficult. It's something that we're kind of actively working on at the moment, because it's sort of the question of now is how do you galvanise the private investment in an environment where frankly, in the last sort of 12, 18 months, there's been investors have moved away from long-term projects and away from technical risk, both of which are pretty central to fusion. So I don't know the answer, but I suspect there is an answer for government involvement. So, for example, the Master Invest Programme in the US is involving government money matching money being raised by investors. That obviously is attractive to investors, and it was based on a model that was used for NASA for their orbital transportation system, will work very well. So if there are approaches that can be taken where government money matches investment money, that obviously helps things for investors. And there are investors who are watching fusion very closely, who are sort of waiting for their move. And I think part of the answer for getting them involved is for the fusion community, to actually articulate how people can invest in fusion and what the remaining technical risk is and what the remaining milestones are. So I think it's partly a job of finding ways to reduce risk for investors, which might mean public involvement, and partly, I think, a way for the industry to lay out a clear path for investors. But it's not an easy question at the moment, and we're not the only sector where there's been a substantial fall off in investment activity recently.
Yeah, it does seem generally that fusion is underinvested in as a sector when you look at, and I think Melanie and I were talking earlier about the fact that the profits of some of the large oil and gas companies are sort of 8, 9, 10 billion over the last quarters. That's just profit in one quarter. So just to put it into perspective.
Some of that would be useful. Yeah.
Good, noted. Adam.
Yeah, just a last thought on that. I think there's also a need to be creative about what kind of investment you're putting into fusion. I don't think it's just necessarily about investing in the big machines or investing in those core projects. I think there's also opportunity to invest in the supply chain, to invest in those supporting technologies that are going to be useful not just for fusion, but for everybody else as well. So I think there's a creativity needed from investors about thinking about the different and supplementary ways they can invest in the fusion sector. Whereas, particularly if those big investments in the machines themselves are quite difficult.
We're going to wrap this session up shortly. I've just got one more question from the online chat. And this question, actually, we could do another hour-long session on. So probably just a quick answer from somebody or a couple of you. What impact could the commercialisation of fusion have on the global energy transition? So I think fusion in its biggest sort of context there. What impact could the commercialisation of fusion have on the global energy transition?
Right. I think the answer is absolutely huge. It's like it's not tomorrow. I think it's very easy to sit here in the UK and think, offshore wind is a great solution, but many countries don't have a shore and the opportunity for offshore wind and the reliance that we have on renewables, and we have a fantastic renewable infrastructure here in the UK now and growing. But many countries, that's not possible. So if you think about how are they actually going to get their carbon emissions down, I think fusion is going to be really important to that. And I think it's one of those things, Adam talked about the export opportunity. The UK is lucky because it has such a coastline, but it is a really big export opportunity and maybe not in the next few years, but I think this is a huge opportunity. And that's why, high risk, but high return.
I think a way that I like to think about it is that fusion offers us a way of maintaining net zero rather than just attaining net zero. And what I mean by that is that if you look at projections of the energy mix in 2050, for example, from the IEA, you still see that there's a huge chunk of fossil fuel generation in the energy mix in 2050. And that's the difficult to decarbonise sectors. So we're going to electrify as much as we can, but there's still going to be things like heat for industry, fuels for shipping, aviation, things like that. So there's still going to be a lot of fossil fuels predicted to be in the mix in the 2050s. And fusion offers us a possibility of getting rid of those last fossil fuels. And so I think that's a huge part. I think that that's a big impact on the energy of the future, to actually be able to do away with those last remnants of fossil fuels in the mix.
Can I just agree? I agree with Melanie. I think the transition, as in moving away from burning fossil fuels, which clearly is a matter of some urgency, fusion is not going to be ready on a short timescale to do that. So I think it's best seen as maintaining a low carbon energy base. And I think that patently, to make a difference to the world's energy, we don't just need to develop fusion as an energy generating technology, we need to deploy it at scale. And the second part of that shouldn't be underestimated in timescale. So by the time you take the time needed to develop it and then the time needed to deploy it at scale, that is still some time off. So perhaps best thought of as maintaining our low carbon generation rather than transitioning to.
Great. Okay. Final thought, Adam.
Final thought. Maintaining potentially, but I think there's more potential there. As a government person, I look on very long timescales, believe it or not. And what we've got here is not something that's transitional. It's not even something that's transformational. It's something that's revolutionary. You're talking about, virtually unlimited energy for like the next 300 million years. I mean, it is revolutionary on those kind of long timescales. And the demand for power is not going down. It's only going up. So, the opportunity for fusion is to meet that increasing demand. And I just don't think there's another technology out there that has the potential of fusion to do that.
So thank you, Adam. So that's a really positive and uplifting end to this panel session. I'd like you all to just extend a warm round of applause to Tim Bestwick, Melanie, Simon, Adam, and James. Thank you. We're now entering panel 2 of our event this morning on UK fusion energy. Panel 2 focuses on a wide range of different topics, bringing you the voice of supply chain and academia. So we're going to look at skills and innovation, talent pipeline, investment and financing, R&D, international collaboration, security, and some of the other challenges that are facing the UK fusion sector today. And I have to say it's been a great pleasure getting to know all of our panellists over recent months, because we've been working on an initiative called the Fusion Industry Task Force that aims to provide a clear and consistent voice of the UK fusion supply chain to the UK government. So I'm going to introduce our next speakers now, who represent different parts of the supply chain and academia, before handing over to them for some initial thoughts. So to my right is Dr. Anika Khan, who is a research fellow in nuclear fusion in the School of Engineering at the University of Manchester. Anika also sits on the Fusion CDT, which stands for the Centre for Doctoral Training in Fusion Energy, Science and Technology, an initiative designed to support PhD students for an exciting career in fusion energy. So I know a lot of you joining today in terms of the webinar will be students, so please, if you want to know about the CDT, we will hear some perspectives, because I think all of our panellists have had touch points with the CDT at some point. To my right is Bethany Jim, who's Business Development Lead for Energy Transition at Assystem, and is completing her PhD on materials for fusion as part of the Fusion CDT. We're particularly looking forward to hearing Beth's perspectives as somebody who has recently transitioned from academia to the professional world. On my far right, we've got Dr. Alistair Morrison, who is Technology Manager at Oxford Sigma. The company's mission is to develop and deliver materials technology, materials solutions, and fusion design services in order to accelerate the commercialization of fusion energy. And Oxford Sigma has been doing work, incredible work all around the world. I'm sure we'll hear about that. And to my left is Dr. Andy Wilson, who is Engineering and Business Development Manager at Kyoto Fusioneering, which is a UK-Japanese SME company, is that right? With a strong UK footprint. Indeed, the company has recently signed a collaboration agreement with UK AEA to advance materials for commercial fusion, and you celebrated a major funding milestone last week. So if you want to find out more about that, and it was $79 million in Series C funding, so congratulations. I'm going to now hand over to Anika to give some perspectives on where we are in the UK, particularly where we are in terms of academia, and your thoughts on how we move this industry forward, and the impact that academia will play.
Thanks, Michael. So as Michael said, I represent the Fusion Centre for Doctoral Training, which is a cohort of several different universities, so York, Manchester, Liverpool, Durham and Oxford. So we're training the next generation of PhD students who will enter the fusion industry in areas like materials, engineering and plasma physics. We also recently, last year, started an initiative called the Fusion Industry School, where we're training people who are already working in industry, so big engineering companies like Assystem, like Jacobs, etc., who are now starting to get these contracts from fusion, from industry. they have the technical knowledge, but they don't have the fusion-specific knowledge. So last year we kicked that off, providing them with like an intense 2-week training course split between York, Oxford, and UKEA, providing them with the skills they need to successfully deliver those contracts. And we're pleased to say that that's going to run again this year, and that's been really successful, attracting people from all over the world, which is kind of one of the key things that was discussed in the last panel, developing that global skills that we need, because it's a global problem. It's not an individual country problem. I also kind of wanted to pick up on developing that pipeline from very early ages, as was mentioned in the last panel. And we also need to make sure we're developing a very kind of inclusive and diverse pipeline as well. So it's targeting people from underrepresented backgrounds, providing them with skills, training opportunities, financial support where necessary to enter the industry. That's really, really important. Bringing them up to the university level, to the PhD level, as well as other skills like the apprentices that were mentioned as well. And then when they kind of enter the industry, retaining them too. I think that's really, really important. I also wanted to talk about, in the last panel, there was a lot of discussions about public-private partnerships, but I think academia needs to be involved in that conversation as well. So transferring knowledge from maybe lower technology readiness level technologies, such as materials and things like that, transferring that knowledge into the industry, and also talking with other industries as well, whether it's aerospace or other applications of the technologies we're developing, such as robotics, such as materials, superconductors, etc. Because one of the challenges that was mentioned is that fusion is kind of a more long-term energy solution. So finding ways that we can get investment in the short term through KTPs and things like that is really, really important. And also bringing it back to the kind of international landscape, having the frameworks in place to allow ease of international collaboration. So things to do with export control have been a big challenge for us recently in academia, and ATAS and visa requirements and things like that. So I think that's really important from the government perspective, to be aware of those issues, to open up, to make our fusion in the UK more collaborative, more open to international collaboration.
Thanks, Anika. So lots to pick up on there in terms of skills, CDT, the point around inclusive and diverse backgrounds and getting people from a wide range of different sectors and industries into fusion. So hold that thought. We'll come back to some of those threads. Beth, what are your perspectives?
So, as you mentioned, I'm currently finishing my PhD in fusion materials at Oxford as part of the Fusion CDT. And I've also recently made the transition from academia to industry, and I'm now working at Assystem in business development. And in this transition, it's become clear to me that career paths are not as clear-cut as I used to think. So it would be easy to assume that I've been an academic up until now, but throughout my PhD, I dabbled a bit in energy policy and in consulting for companies and startups. And I discovered that I really enjoyed having that global view of how things work. So towards the end of my PhD, I had real trouble deciding whether to stick with material science or whether to pursue a policy role or whether to pursue something, more commercially focused in the wider energy industry. So all I knew, and I think this was touched upon in the previous panel, all I knew was that I wanted to make a positive impact on the environment. But I wasn't sure in what capacity. And, I've had friends who are finishing their PhDs who have had similar issues, particularly in finding what kind of role they are suited to after academia. And I think part of my struggle was to do with the lack of clarity in career pathways. And I don't think that this is a problem that is limited to the fusion industry. But what I can say is that to me, the fusion industry felt quite fragmented. And that's a good thing too. There's lots of new players, lots of investment going into fusion. But I think I found it hard to understand what kind of options were available to me, particularly outside of research. So since then, I've transitioned from quite a narrow focus on a niche area of fusion to a role where I now have a much broader perspective of what's happening in the energy industry. And throughout this, obviously, I'm still committed to progressing fusion, such as through the Fusion Industry Task Force, which Michael mentioned. But as a sector, we really need to work on not only the attraction piece in recruitment, but also on the retention of the highly skilled people who have made it to master's or PhD level, but don't necessarily have a clear view of what kind of role is available to them. And as Anika mentioned as well, we need to think about how we can attract more women, more ethnic minorities to not only fusion, but to STEM in general. And, how can we do this much earlier on? And diversity of thought is so important in advancing innovation, and it doesn't make sense to neglect such a large portion of the population in our recruitment efforts. We also need to be much more inclusive of people from less privileged backgrounds and of those who haven't followed the traditional academic route as well, such as myself. So, another thing to consider is geographically, how can we stimulate more involvement in fusion from outside of the Oxfordshire area and the Golden Triangle? And I know that I'm saying this as an Oxford postgraduate student, but I'm from Exeter. I fully recognise that there are areas outside of the ones I just mentioned who have a lot of potential to get involved in fusion. And I think if you consider as well that so many of the key skills in fusion, such as in plasma physics and materials and magnets, are located in centres of excellence around the UK, this is something that we really need to focus on. And, equally, there are many routes outside of academia that can help people to get involved in fusion, which don't necessarily involve further study. You don't need a science PhD, you don't need a background in STEM even. And I think this was alluded to in the previous panel. There are a lot of support functions that are a key part of the industry. And something that I've observed in the work since joining the workforce is that a number of senior figures in the energy industry have built up a toolkit, so to speak, across their careers from, a number of different roles, whether in sales or HR or consulting or finance. The list is endless, really. So for anyone like myself, making that transition from academia into industry or between other parts of the workforce, there are so many transferable skills which are applicable to fusion. Sorry, I'm nearly done. And something that Simon Bowen, interim chair for GBN, recently mentioned at a conference is that only 5% of jobs in the nuclear industry actually require nuclear-specific skills, and that the industry needs to overcome its snobbery. So I'm not sure on the exact percentage of fusion-specific skills needed, but perhaps this is the kind of thinking we can apply to the fusion sector and address the recruitment of cross-sector skills like project management, construction, and welding. And of course, part of this is understanding where the skills gap lies and the number of jobs needed. But, eventually we can create a capability map with quantifiable targets, which industry, academia, developers, and government can all work towards together. So I think to make sure we have the skills pipeline that we need for the next few decades, we really need to create a coherent training program across the whole fusion industry, not just nationwide, but globally too. And that's something that the previous panel also alluded to.
Brilliant. Thank you, Beth, for your unique personal perspectives and the sort of gaps in the career path that perhaps exist in terms of getting into the professional world. Turning now to Alistair, be great to hear your perspectives.
Thank you very much. So I'm Alistair Morrison, Oxford Sigma. We are a small company, mostly providing fusion materials, sort of specialist technologies that we're developing in-house and services that we're providing for other people to help them understand what's going on inside their reactors. It's been mentioned already, and I think Simon said it in particular, is that materials is a bit of an international problem. Everybody's going to need materials, but the challenges are definitely global. And there is a global community that has long been addressing that in academia. But going from that kind of understanding of the science into something that's an engineered solution that has the safety and assurance in the materials properties at its heart, so whether that means qualifying materials or having materials that you can actually get in a supply chain now, are really severe challenges to overcome. And that's something that we are addressing on a daily basis and provides a lot of interest.
Brilliant. Thank you, Alistair. Turning now to Andy from Kyoto Fusioneering.
Hi everyone. I'm Andy from Kyoto Fusioneering. We can shorten that to KF. It's quite a bit easier. So I came out of a PhD looking at nuclear and energy storage. I was in conventional fission back then. I went into Bayes doing energy storage for a little while, and then had the opportunity to join KF. So KF is, I guess the clue's in the name. We're an engineering company, but we're also a technology company at heart. So we're not your conventional fusion plasma developer. We focus on pretty much everything from the first wall all the way out to power generation. That's obviously a pretty big area. So we're focused right now on our core competencies as we grow. So that's primarily blanket design, development of tritium systems and fuel handling. And we also have some products that we're bringing to market primarily in heating and gyrotrons. So yeah, I'd like to touch on a few bits from the last panel just before we get started, because they're passion points for KF. I guess I learned a lot last week at the Fusion X Invest event. That was really good. And there are lots of different types of investors. So you've got the investors who are looking for those financial returns, but you've also got the investors who are kind of focused on just bringing this technology to the market, and they're much further time horizons, because they believe that the revenues will come once this technology comes to fruition. I think they're right, and I also think that both kinds of investors are very important. I completely agree with Tim and Adam when they say we need to think about spin-outs from fusion and how we generate revenue from that. But I also think we need to think about the commercial case from fusion. The truth is, well, I would argue that the truth is that fusion is still some way down the line, and the market that we're going to be selling into is pretty uncertain. The idea that you're just going to hook up to a steam cycle and sell electricity is maybe a little myopic, and I think Kyoto Fusioneering is placing a pretty big bet on the promise of fusion being a wider set of markets, and that means going to high temperature, and that's what we're focused on as an organisation. But I also think, bearing in mind a flexible output from fusion is going to be quite important. In terms of skills, I think everyone's hit on that pretty well. I think the big passion point for me is that fusion is exciting, and there are real challenges to solve. It's a multi-billion dollar, if not trillion-dollar problem, but that's $1 trillion for us. It's for the scientists and engineers, and that's something really special and really exciting. And finally, I think whilst it's not as exciting, investing in the supply chain is going to be very important. This stuff isn't going to materialize overnight. So yeah, I'll leave it there. But yeah, thank you.
Great, thanks, Andy. So some really different perspectives. We started with skills. We had Beth's personal perspectives. Alistair talked about the global community in fusion and gave some insights in terms of his company looking to accelerate the commercialization of fusion with material science. And then Andy looking at the commercial case for fusion as a supply chain company. So I'm going to start actually with skills, given that all of you have gone through a long academic career and then entered the professional world and are now working for private businesses and academia at the University of Manchester. So turning to you, Annika, and maybe others can join in on this, how do we encourage young people to start a career in fusion? And building on that, what are the lessons that we can learn from the success of the fusion CDT?
I think, as has been mentioned previously, we need to start at a very young age. As Melanie said in the previous panel, incorporating fusion into the curriculum as early as possible is really important, because there's just such a lack of awareness of fusion, how it differs from fission. Not many people really understand what it is. So I think having that education built into the curriculum is really important, and making that a global thing, not just in the UK. Also just making people aware of what opportunities are available to them through outreach, through targeted placements, as we mentioned, making sure we are being inclusive and targeting people from underrepresented backgrounds as well, through funding, through internships, and kind of exposing people to what opportunities are available to them in STEM, in science, and like the technology side of things, but also if people are interested in policy, in regulation, in health and safety, in all these other kind of things that we need in such a broad area, I think it is really important to show that there's opportunities available for everyone, whatever their interests are within the fusion industry is really, really important.
Okay, and Beth, how important was the Fusion CDT in terms of helping you on that path to a professional career?
I think the Fusion CET was really an integral part of my learning in the fusion industry. And I think the great part about it was that you didn't necessarily just focus on what you were studying. So obviously my PhD was in materials for fusion. But we also learned about the broader industry, about the plasma physics side, which I wasn't necessarily so good at. But, it was a really good chance just to learn about the broader industry. And I think, part of the Fusion CDT's kind of core focus is to make sure that each student does know about the wider industry. I think that is really important. And I think, even before PhD level, we definitely need to be introducing fusion, at a much earlier stage in schools. I think that, there's a lot of focus on talking about, what is the difference between fission, fusion, all of that. But I think we also really need to focus on the exciting parts, and, what are the benefits to society as well, not necessarily just the scientific reactions that are happening. And yeah, I think as Melanie mentioned as well, it's very much about communicating that vision of a clean, sustainable future, because I think a lot of young people really do focus on that vision and how can they achieve it, how can they be part of it. So I think just, really building that inspiring story. And I think it's on the Get Into Nuclear website. They've got some really, really good career stories of people in the industry and how they've, taken different steps in their career paths. And I think potentially that's something that we can do in fusion as well, just really make the pathways a lot clearer, have those exemplars of people within the industry.
Yeah, coming to Nika, did you want to go?
Yeah, just to add, I think that was a really good point, Beth, as well, about how fusion links into all these other topics that people are already studying. And so you can link it in at so many points. So even if you don't have a specific fusion-related module or topic or whatever, linking it into energy storage, for example, which Andy mentioned, or big infrastructure or engineering projects or things like that. So finding all the other kind of synergies with other existing topics and in industries, I think, is a really good way that we can bring more people into the field as well.
So kind of building that talent pipeline inclusively. Alice?
Yeah, on that talent pipeline front, one of the comments we get with our US clients is that they don't have access to that the same way as we have in the UK, where the Fusion CDT has been going on for long enough that it's really making a material difference in that engineering challenge side of it. And it's something that we as the UK should build upon in other programs and make that something that we can export, either as a principal or the people that are coming from it. And I wanted to add anecdotally, I didn't take part in the Fusion CDT, but I did happen to do my PhD at the same time, and I was able to benefit from sneaking into some of the lectures that they were having to get a little bit more of that grounding, and it was very valuable.
I'm going to turn to Andy now, because you actually started your career in nuclear, did you not? And your academic background was more on the fission side. So what was the motivating factor to get from fission to fusion?
Yeah, sure. I mean, for me, it's about the excitement of fusion. I actually started my PhD looking at producing hydrogen from high temperature fission reactors right around the time that the Gen 4 International Forum dropped the target temperature of the very high temperature reactor down to 750, which quickly made a lot of my PhD research defunct at that point. And I kind of felt, and it's actually coming back a bit more now, but I kind of felt like the fission industry had lost a lot of its ambition when I finished my PhD, and I think that was my big motivation to move into energy storage, which was very exciting at the time, and then again into fission. And I think that narrative, that excitement was what really brought me into the industry.
And I guess this question for both Andy and Alistair, what are you seeing in terms of recruitment? What is the kind of profile of a young person who's wanting to join your organisation? What are the kind of CVs that are landing on your desk, and what is the thought process in terms of recruitment and the type of people and the type of skills you want to recruit?
I'll go on that. As a materials specialist, the thing we're really looking for is people that have some kind of grounding in materials. And as it's not a subject that really gets taught in school, so at A level there's very limited sort of coverage of what it is. It's quite hard to pick that up without getting graduates. We're taking part in the nuclear graduates program, and we receive graduates through that we can help to expose to materials a little bit more that have maybe not done that previously. We're also looking to recruit people that are specifically from a materials background and are interested in the nuclear side of what's going on. And we're looking to use the fusion industry program to bring in interns for summer placements to help get them exposure that maybe they're not already getting through their undergraduate courses.
Yeah, and I think it's a little bit different for KF actually, because we're such a generalist organisation. Actually, we hire a lot of non-fusion specialists. So we hire a lot of mechanical engineers. We also focus on chemical and process engineers because we're in a different discipline essentially than the plasma developers.
And Anika, from the other perspective, what are you seeing at the University of Manchester in terms of young people? Where do they see their future career paths?
I think similar to what Beth said before, there's a real desire to make a difference. It's not enough just to, want to enter a career just because you want to earn money, etc. Well, that's important, but people really want to make a tangible difference to all the world's problems, and I think fusion is really exciting to those people. I'm starting to see more of an interest from a younger age, actually, which is really encouraging. So we've got now undergraduates doing dissertation projects related to fusion and really doing really important work there, then master's level and PhD level as well. I have to say, the amount of applications we get is just a huge amount, like it's increasing in terms of applications to the Fusion CDT. So there's not a shortage of people who are interested in fusion, but we need more money to be able to support all those people, because every year we have many more people that are so talented and more than capable and would have such a positive impact on our fusion industry, but we just don't have enough funding to give a PhD to all of them. So I think definitely a need for more funding for more projects, both at the PhD level and also other jobs in fusion too.
And I just wanted to turn to Beth. You mentioned diversity of thought is really important in advanced innovation. Are there any particular examples you can give either from your professional background or your academic career that really solidify that thought?
So just speaking from, I guess, the academic environment that I was in prior to joining Assystem, I think something that I always noted was how international all of the research groups were. You had people from all over the world coming to study in different academic institutions across the UK because of the, renowned facilities, the renowned knowledge base that is here already. And I think it would be a real shame not to capitalise on that. I mean, as mentioned in the previous panel, maybe there are some cons to that. Maybe we'll have a little bit of a drain in the UK as well. But at the same time, you're opening up opportunities for global movement. And I think, a lot of young people also do want to live around the world and try different things. So I think, that's something that we need to think about. And, obviously there are issues with export control and things like that Anika mentioned. And that's something that we need to think about because, too tight controls will mean that we won't have the resources we need for our skills pipeline down in the future.
Yeah, no, completely agree with that. And I think, yes, we do have a really diverse student base, and there are loads of people from many different backgrounds, etc. We can improve, we can always improve there, but it's not bad. But there's a real drop-off when you go into the industry or higher up in academia, and the higher up you go, that does fall down, and we need to ask ourselves why that is and what we can do to change that.
Okay, and just talking about export controls and security and sort of moving from academia to companies like Oxford Sigma, KF, the supply chain, are there any perspectives that you might have on that security piece and export controls and that sort of transfer of knowledge from academia to industry?
It's quite a broad topic, but yes. So I think there are real challenges around how we take what's been an academic community globally and identify what some of the risks are to actually building power plants and who can access neutrons to use for the purposes of breeding fissile materials. And at some point, the sort of understanding behind that will need to become something that is covered by security measures, because they could be used in particular ways if you're not careful. In terms of how that makes sort of academic transfer across, there's a definite issue in terms of that, and I don't think it's being addressed fully at this point. Export control on particular material topics that have dual use is an issue, but they also happen to be the materials that we tend to be interested in from being able to deal with the fusion environment. So there's a big challenge there to work out how we do that. But then further than that, how do we make these exportable devices and designs and technologies globally? I don't have an immediate answer.
Andy, did you want to come in, particularly from the perspective of a UK-Japanese company with a strong UK footprint? What are you seeing?
Yeah, sure. I mean, we've seen big problems with export control, and it does slow things down. As I said, the materials are a big issue around that. I do think it's important. As we say, a lot of the materials are dual use. There's all sorts of issues around tritium, around proliferation. I think it's an early stage, and it's very difficult to answer in a lot of detail.
Okay. I just wanted to pick up on something Annika mentioned around the fact that the University of Manchester and presumably other universities across the UK that focus on fusion and advanced engineering have a very international student base. So is it a misnomer to talk about sort of UK fusion, or is it one where we're going to have to work even more collaboratively, think even more internationally in terms of the long-term perspective?
Short answer, yeah, I think it definitely is. It's an international problem. We're all working with each other anyway, and if you look at the supply chains, we don't have the raw materials to make the components that we need for a fusion reactor. So it's very short-sighted to say that this is a UK-only issue. It is a global problem, and we need to be working more collaboratively.
Yeah. Any perspectives from the representatives from three companies with all with international footprints? And I know your colleagues, I think, are in the US at the moment, are they not?
Yes, it's something that's got to be carefully considered. As Nika says, there's not an answer in collaboration. It's probably what needs to go on, and it's government-to-government collaboration that will be needed to address some of those issues for us to be able to exploit technologies ultimately.
Yeah, I think through a KF lens, the international collaboration is very important. Bringing that Japanese supply chain, the manufacturing strength in Japan to the UK is core to KF's business mission. But equally, I think there are opportunities in the UK with my sort of Bayes head on. I would say that there's a lot of communities that have been underinvested in, particularly in the north, and fusion is a great opportunity to reinvigorate those manufacturing centres. So yeah, I think it's global, but there's also a lot of opportunity in the UK.
And how useful is it that countries like Japan are following the UK in terms of regulation? Because I think they announced their fusion strategy over the last 4 to 6 weeks or so.
Yeah, I mean, I speaking to a lot of people in the industry who say that the UK regulatory environment is great. It's one of the big risks of fusion that we start to regulate it like nuclear fission, and I think that could be a real problem if we fall into that pitfall.
Okay, I'm going to open up to questions from the floor. So if you have a question, please put your hand up. We will give you a mic. Please identify yourself and your organisation. Just to get the ball rolling, I've got a question here from the online chat. This is to all of you. Which skill sets will be critical to developing or delivering commercial fusion?
Which skill sets won't be critical?
Okay.
Yeah, everything: science, technology, engineering, regulation, the legal side of things, health and safety, construction, literally anything you can think of, we need them.
Okay, so follow-up question to that then. How do we get those people in those sort of other industries around fusion, particularly professional services who might not think of fusion to look at fusion?
I think definitely having more communication with the public, whether that's through media, social media, other kind of avenues, events, etc., that open up the industry to the general public is really important, just to make sure that they're aware that there are these opportunities and these jobs available, and making them attractive to them as well compared to other industries.
Okay, Beth, any perspectives on skill sets having kind of made that jump from academia to professional life over the past 2 years?
Yeah, as I said, I struggled with knowing exactly what was out there in terms of roles, and I was coming to the conclusion that I didn't want to stay in a research-based role. And I think there probably are other people out there in a similar boat. And, you know, as I said before, there needs to be clearer career pathways, and, you know, just we really need to address the barriers to accessibility, really. I think just making fusion much more, I mean, I think in a lot of people's minds, you know, in the general public, fusion is, as a lot of people have said, it's, you know, years away. It's something that they can't get involved in. But actually, there are so many roles which they can get involved in. You know, as Anika mentioned, all the, you know, the finance, the HR, the citing, that, you know, so anyone doing geography can get involved. It's really not a case of you must be doing fusion science to get involved in fusion.
Okay, and how important will and this is another sort of follow-up question from the chat, how important will digital be in terms of developing and delivering fusion? Any thoughts on that?
I can add from a Manchester perspective. So we've recently appointed a digital chair in collaboration with the UKEA. So it's a huge area that's going to be required for fusion to advance in terms of modeling kind of experiments and building like designs and things like that from an engineering perspective. And again, there's so much crossover in terms of the skills there. So you've got people working with like Omniverse and all these kind of big digital companies, things like with AI and things like that. Fusion needs that in order to accelerate delivery. So a huge crossover of skills there and very important.
Okay, any further thoughts on digital?
Yeah, I mean, something that I think is really important for us is digital twinning. You know, they're putting diagnostics in a fusion reactor environment. It's a pretty horrific place, and you're gonna burn through those diagnostics pretty quickly. So I do think digital twinning is going to be huge in fusion.
Yeah, and I have to say, I sat through an hour-long presentation last week on digital twinning, and if you haven't checked out the capabilities and fantastic possibilities of digital twinning, please Google it, YouTube it. It is incredible. It will revolutionise the world. Any further thoughts on digital?
Yeah, just one last thought. The fusion sort of concept designs and getting to power plants are very, very integrated problems engineering-wise. So it's difficult to say, oh, we're just going to pick that material and it'll be fine, because minor changes in what you put into the reactor may have quite major impacts on, say, the efficiency. So it's the kind of whole systems engineering problem. And that really feeds into the previous point in terms of skills as well. What fusion needs is people with a lot of agility from an engineering perspective who can deal with many different problems in different areas that aren't necessarily their specialisms. And that's something that I don't know how we're trained, but the UK has a history of being quite good at that, so hopefully we can continue.
Okay, just pivoting back to skills, and I think you mentioned this in your opening piece, Anika. What can the UK government and private sector do to encourage the uptake of skills for fusion? What do we need to do next, and how urgent is that?
Yeah, it comes back to money as always. I think having more investment in all kind of positions, whether that's apprentices, whether it's PhDs, degree courses, investment in schools, specific programs, encouraging people to get into these kind of STEM areas. I think that's really important. And from the policy side of things as well, also building frameworks that kind of integrate the approach across all the, across the private sector, public sector, and academia, so they're all kind of more joined up and more cohesive, I think is really important.
Yeah, and a follow-up question to that, and maybe aimed at somebody else, is there an opportunity for the supply chain to unite in STEM outreach to support schools in preparing students? Have you thought about that? Is that something you might do in future?
Yeah, I don't think we've gone to quite the school level, but it's certainly food for thought. But yes, KF is looking at funding PhDs and funding opportunities in education, and we're also looking at developing an apprenticeship program over time as well. So this is some stuff that we have given some thought.
Okay, and Alistair, you mentioned the internship program that Oxford Sigma's running. What's the kind of uptake on that and level of interest? Are you finding lots of people?
It's through the UKA's Fusion Industry Programme Challenges and their funding. And we've been having sort of upwards of 40 or 50 applications per internship position. Our big challenge is being able to have the time and resources to run those properly and to give students a proper introduction to Fusion in a way that is stimulating and engaging, and we're not just getting them to sit there and run through spreadsheets. Beyond that, though, I think the question on should we be going out to schools with STEM much more is definitely yes. We welcome local students for work experience placements on a regular basis into the office, but it is the time that takes from what is potentially already getting towards being quite overstretched, where we don't have the specialists across the industry and they're being snatched up very readily. So making sure there's a balance across that is going to be key.
Yeah, and Beth, you mentioned about making sure that we interest people outside of the Oxford area and the Culham area. How do we do that? Are there any perspectives on how we might do that, particularly in terms of schools, apprenticeships?
Yeah, I think obviously with STEP being located at West Burton, there probably is going to be a lot more in that area in terms of outreach, in terms of information that will be publicly available surrounding Fusion. But yeah, I do think there are many areas outside of Oxfordshire which probably could do it with a lot more of a concentrated effort in terms of outreach. And, I find that it's not only a case of with outreach, probably with funding and investment into schools as well. I think, a lot of the regions outside of Greater London could really benefit from that increased funding. In terms of having apprenticeships and, just having, internships at schools, I think that would be something that's really, really helpful, because at school I didn't really know too much about Fusion, and I certainly never would have thought that I would end up, working in the sector at all. So, yeah, I think just having even one representative come to your school is just so valuable. And I think, any child can benefit from that. And again, seeing the career pathway as well, I think that makes it so clear to somebody what is actually achievable. And in terms of, the ethnic minorities as well, I think seeing someone like yourself in a senior leadership position is so important. And I think it definitely makes it a lot more attainable.
Just to add to that, so I think we need to think much more broadly as well. So using things like we saw during the pandemic, how useful online kind of tools are, social media. It's really important to go to schools, but there's so many other avenues. Like young people are getting their information in so many different ways these days, whether it's like through TikTok or Snapchat and things like that. We can show what we do like on a day-to-day basis and show how exciting it is using these kind of different technologies. And we need to utilize the young people in our industry who are they're familiar on how to use it, they use it very naturally, very organically, and they can tap into that and combine that with the really exciting work we're doing and showcase it to such a big audience using these kind of avenues.
I just wonder, are there any questions from the floor for the panellists at the moment? Okay, Valerie?
Okay, I'll just make it quick. Are the current pay levels for apprenticeships and PhDs sufficient to maintain students in those positions? Because just having spoken to other, not nuclear fusion specifically, but other sectors, they're at breaking point in terms of retaining students and drop-off rates because of the cost of living.
So a question from Esme from BBC.
Yeah, really good question. I can't answer about the apprenticeships because I'm not really involved with that, but I can talk from an academic perspective. So there has been an increase in stipends, but there's a huge variation depending on whether your PhD is industry funded, etc. And yeah, it definitely needs to be higher. I've seen similar things, with the cost of living crisis, it's really, really difficult. The problems get worse, if you talk about accessibility, if people got caring commitments or need to go on maternity leave and stuff, it's pretty horrendous, especially if you're an international student. The whole visa issue makes it so much worse. And then academia in general, not just Fusion, is pretty precarious from a job perspective. Once you do your PhD, if you want to stay in academia, you might have short-term postdoctoral positions, some as short as a few months. which is pretty shocking, really. The system does need to change in order to retain talented people from an inclusive and diverse backgrounds, because at the moment I think it's pretty unsustainable.
Yeah, and I guess a question for all of you. How difficult was it to fund your PhDs? Because I think all of you are PhDs. How difficult was that? How challenging?
So I had a funded PhD through the Fusion CDT as well many years ago. Yeah, you do have to. That was a long time ago. It was a very different environment. It was enough for me to get by as a student, etc. But I think today's climate is so different that we need to be giving more options and more opportunities to people.
Beth?
Yeah, I just wanted to echo Anika's thoughts there. I mean, I wouldn't say if the funding is inadequate, but it's enough to get by. But living in the Oxford area, it certainly wasn't cheap. And I think that's something that I've also had issues with towards the end of my PhD as well. Obviously, being hit by COVID, it meant that a lot of my experiments were pushed back further, and I wasn't eligible for further funding. So I guess that's part of the reason why I'm now in a position where I'm writing up my thesis and working. But I think there are many others who have been hit by the pandemic who are in a similar situation. And even before COVID, I think there definitely needs to be possibly a reconsideration about the remuneration in undertaking a PhD, because although it is, I suppose, a really good opportunity to be funded to do further study, I think you also come to terms with the fact that you're taking a huge pay cut compared to your peers who are going down a more industrial route.
Yeah, Alistair, any further thoughts?
I think that continues beyond the PhD level. So although funding there is difficult, it's postdocs as well, and the timeliness of it. So anecdotally, again, I was forced into industry rather than a postdoc position because both my partner and I couldn't both be postdocs and make it work. Not necessarily a bad thing from my perspective now, but at the time it wasn't ideal. And I think it's the timing on funding that's a really big issue. So a lot of initiatives to tie together private and public activities are time limited, so they may be 18 months or 24 months. But if you want to get a postdoc involved, you really want to have at least 2 years, because it's going to take a few months to hire them. And if you want to get PhD students involved, it's 4 years at least of funding, and that isn't achievable within sort of the current sort of grant schemes that we can access.
Yeah, and then Simon Barber in the first session mentioned the fact that in terms of the sequencing, you've got to get that sequencing right, get ahead of the curve and plan strategically. Andy, any further thoughts?
Yeah, sure. I mean, I came out of a job in offshore construction when I started my PhD, and I think had I not had a fair amount saved up from that and a very supportive partner, I certainly couldn't have done even with the CDT and the funding stipend, I couldn't have done it without having that background. And I think without really increasing the amount available for stipends, you're not going to get kids from underprivileged backgrounds into it at all. I don't think that's realistic.
So I think, Esme, the answer to your question is there's scope for significant improvement. Do we have another couple of questions, Valerie?
I found the story of First Light Fusion very inspiring, spinning out of work that was done as PhD thesis. But that was way back in 2011, and we haven't seen a UK homegrown spin out in fusion really since then. So my question really is for the CDTs: are they connected with innovation departments in universities and helping to create those new companies in fusion?
So I think each university, they have these innovation schemes and things like that our students do have access to. And I'd like to add, I believe Oxford Sigma, you spun out of a university as well. So there is, and that was with a Fusion CDT student as well, right, Tom? So yeah, it's happening. We can do a lot more for sure. And I think we're utilising the university's schemes, but yeah, definitely somewhere that we can increase our focus on.
One more question, gentlemen, from Bassett Law.
Yes, Craig Taylor, Bassett Law District Council. Really interesting to hear what's been said about the looking to focus on underprivileged young people coming through, and so not just young people, but across the whole spectrum of ages, because within the Bassetlaw area, that's something that is, well, I think it was part of the decision of why West Burton was chosen as a site, because there's a real need to upskill and create higher paid employment opportunities. There's a lot of warehousing, distribution, and so really the discussion around that career pathway, I think, is critical for the young people to be able to map out what the future could look like for them, and to have a series of stepping stones for them to get there. I think that's really critical, and just be interested to hear any thoughts of practically how that could be moved forward.
Any thoughts, particularly with a focus on West Burton, North Nottinghamshire, South Yorkshire, North West Lincolnshire?
I think it starts with public engagement, as is mentioned several times. So just making the community aware of the opportunities that are going to be. I'm not personally involved with it, so I can't say specifically what they will be, but for sure making people aware of the opportunities available to them, what skills they could develop and what they could go into, I think is going to be really key. Going into schools, going into kind of community events and things like that. So we're really targeting a broad kind of cross-section of the community, I think is going to be really vital.
I think adding in the kind of actually building things will become quite an interesting challenge when we get to it. The number of components inside any reactor are going to be enormous, and the sort of production management and looking after them is going to need some very skilled technical people who care about it as much as anything, want to keep things clean and tidy. And I think that's going to be a challenge that hasn't yet been addressed in the manufacturing supply chain. And we'll take people with skill sets in managing lots of things that are going on at the same time, and then trying to do that in, a nuclear environment.
I think just to take where, certainly from a local perspective, success for us is around someone who's at school now having a future career at that site, not just about parachuting other technical people in. Clearly that will be required as well, but it's actually the people coming from the schools at the moment will be how we would gauge success.
Yeah, and just a question maybe back to you. I mean, what are you seeing and hearing on the ground in Bassetlaw, and just generally in the East Midlands and the county?
Yeah, there's certainly huge amounts of enthusiasm for the STEP project. The announcement was made just last October time. So as a council, we're very much gearing up and working with partners, UK, AEA, Oxfordshire Advanced Skills, County Council, neighbouring authorities as well. So the network infrastructure is building in terms of how we're collaborating and working together. And skills and the skills pipeline is one of the major areas that's being looked at as one of the first things that needs to be put in place. Being honest, there's a lot of interest amongst academic deliverers, which is taking some knitting together to make that into a coherent offer. That it's not seen that providers are in competition with each other. It's trying to draw all of that together. There will be a training academy built at West Burton, I believe by 2025, which will host apprentices, which will be similar to the Culham facility. So that is a real positive step, that when that starts construction will really make things tangible for local people. But yeah, there's a lot of groundwork happening in terms of certainly the network and the partnership working at this stage.
Great, and it really would be symbolic, I think, if we could have the world's first fusion reactor in North Nottinghamshire, where it was the centre of the sort of UK coal industry, along with the northeast and Wales for many years. Any final perspectives from the panel? Any comebacks on that? Okay, we will wrap up now. So thank you very much for joining us today. Hope you'll join me in a warm round of applause for our panellists, Andy, Anika, Beth and Alistair.